the marble's gonna hit the dominoes, which then knock this over, which then pulls up this little ramp which has food in it, and it's gonna pull it up, dump the food out.
Five, 4, 3, 2, 1.
Yes!
All right, here we go. Oh, that's working.
That's awesome.
Nice.
Well, thank you for tuning in tonight or turning in today to learn more about the 2025 Engineering Design Challenge Feed the Animals. And thank you for taking time to consider this as an opportunity for young people that you know or work with. So what we'll be talking about tonight are the basics that incorporate or encompass the 2025 Engineering Design Challenge. We'll talk about the resources that are available to support coaches, teams, and the young people that are participating in this challenge. We'll also go over the things that we've seen and we hope that young people and the teams learn as they participate in this particular event. We'll talk about the involvement or the roles of journaling and the overall presentation that's a part of this contest. We'll talk a little bit about the showcase event and the value that brings and what's expected of the teams. Then we'll talk a little bit about support that we provide for the teams or that is available to teams and coaches and young people. And if you have questions, I'll give you an opportunity of how to reach me. So I'm Margot Bowerman. I'm the North Dakota 4-H STEM specialist. And this is one of my favorite events because of what I see young people gain in this. And just because it's a fun event with a high potential for learning. So the basics of the Engineering Design Challenge, and don't get thrown off by the term Engineering Design Challenge. What it is it's creating a Rube Goldberg machine. And don't get thrown off by the term Rube Goldberg machine either. Rube Goldberg was this cartoonist from a couple of decades ago, and he would draw these really elaborate machines that did a really simple task. So we made the simple really complicated. So the basics of this challenge are to create a Rube Goldberg machine that has at least 7 steps or transfers of energy. And you'll see what that is once you get in, what I mean when I say steps or transfers of energy, when you get into building your machine or working with your team to build the machine. So the basics are it needs to have 7 steps or transfers of energy. It needs to solve the challenge, and this year's task or the challenge is to feed the animals. It has to incorporate the theme of feeding the animals. So that's an opportunity for young people to have a little bit of fun with the theme. And it's for young people in grades 3 through 12. And it's for teams of 2 to 10 young people. So building a Rube Goldberg type contraption or machine that feeds an animal by placing food in a feeding area. So the food can be either actual food or it can be a representation of food, but the food the judges or the audience clearly needs to see what the food is for the animal. And then the food must be placed in a feeding area. So there just has to be some type of designated feeding area. It could be a bowl, it could be some type of container, it could be an area on a mat or a towel, but the task for this year's challenge is to place feed in a feeding area. And young people, your team can decide what the type of animal is that you're hoping to feed in this. So it can be something really domestic like a dog or a cat. It could be livestock like goats or sheep or horses or pigs, or maybe you want to think outside of the box and maybe it's a way to feed goldfish or a snake, or I'll leave it up to you. I'd love to see what the creativity and the imagination that comes through it is. So it's up to you what type of animal that you choose to feed. So the resources that we have are starting with our North Dakota 4-H Engineering Design Challenge website. And in the below this video, I'll put links of how you get to the website. So that's a great place to start. And as part of the website, there are links that will click to many of these things, many of the resources. But the links can also be found in a Google folder, and I'll share that Google folder link with you. These are some of the resources that are in that Engineering Design Challenge Google folder. It's under if you're familiar with the Google Drive for North Dakota 4-H, it's under contests, and then it's under the Engineering Design Challenge contest. And then the real go-to resource is the guidebook that lists everything you need to know, or hopefully everything you need to know to participate in the challenge. So that guidebook will list the rules, give you some hints and the things that you need to know. It'll tell you a little bit about how to display your machine. But it's a primary resource is that guidebook. So this guidebook that I'm talking about, what is in the handbook? So through the handbook, it'll talk about who can be on the engineering design challenge team, which I did just mention. It's for young people in grades 3 through 12. And you don't want a team larger than 10, but there's a lot of value in having young people work together. So you want at least two. There's information on how to register. There's information on the machine specifications, so things that have to be in there, like the seven steps or transfers of energy, and it talks about what we mean when we say a transfer of energy. So, for example, you might have a row of dominoes that tip over, so that would be one step. We're not going to count 7 dominoes as 7 steps, but the energy that goes through dominoes would be one, and maybe that last domino hits a ball, so that would be the second energy, and maybe the ball falls into a bucket that raises a pulley. So that would be another step of energy. So we need 7 steps of energy. And one of those steps can be, or you can add it as an additional step, is the food going into the feeding area. So those are some of those that's what I mean when the specific challenge specifications, it describes what we mean when we say feeding the animals. We're also looking for young people to understand what the engineering design process is and the stages that young people go through. And we'll talk about that in just a minute here. There's also a section on what type of record keeping should happen. There's a frequently asked questions, but if you don't find your question answered in there, please don't hesitate to reach out to me or your county agent. There is information on exhibiting your machine at county and state fairs. There's a little bit about what happens during fair judging or achievement day judging. So there's guidelines in there as well as what the form the judge will use to judge your machine. So you'll see the criteria that the judge will use when they're examining your machine. And there's also an engineering design journal to give a guide. It doesn't have to be strictly that way, but it's a guide for how teams might want to think about taking notes and keeping track of the work that they've done on their machine, because oftentimes they'll forget some of the steps that they've done. So this has been a really valuable opportunity or place for young people to see the importance of note taking. So my favorite part, though, is what I see young people learn when they participate in the Engineering Design Challenge. And they learn a variety of different skills, and just a few of the ones that come to the top are problem solving. And so that really much of this comes from when we do evaluations or that conference judging, when we talk to young people, what they're able to articulate about what they've learned. So they often talk about the learning how to solve problems. And that's the engineering design process, is helping young people learn how to solve problems in a systematic way. They certainly get a lot of critical thinking in analyzing steps in their machine, and what's going right, what's not going right, and how to fix it. So critical thinking is one that really rises to the top. They also learn, so we ask them to work as a team. So young people also learn a lot about how to communicate with each other, and as well as the judge when they do their showcase experience. But they're really amazing at articulating what they learn about communicating with each other so that they can collaborate well and work well as a team together. Some of the greatest lessons I've heard young people articulate have been in an engineering design challenge when they talked about what they learned about working as a team, about things that they learned about themselves, things that they learned about others. And they're really, I say this a lot, but it's amazing how they can articulate what they learn about working as a team. And then, of course, the Rube Goldberg machines really lends itself to creativity. So that you have kids that like those tinkerers that have maybe some of that engineering inclination, but the theme aspect will also bring in those young people that really have that creative side and like to put a story together or tell a story. So it's a good opportunity for young people to see the value of having different people on their team. And again, they articulate that amazingly well. So creativity certainly has a role and young people will talk about what they learn or value as part of the engineering design challenge. They also talk about leadership opportunities and what it means to be a leader, but also how a leader works well with a team and what it means to be a team member. And so certainly kind of as part of that, what I'm articulating there is really things about social skills. then so that's the fun skill, the way the youth development side where we can see young people growing in skills. There are some specifications or aspects that we do hope that young people, and they do articulate things that they learn through the engineering design challenge. And so we highlight simple machines, and we'll go through those in just a minute. We talk about energy transfer, so they're learning about energy transfer. And for those young people that haven't had that yet in school, it gives them almost a leg up when they start talking about that in school because they have some familiarity with those concepts, so that it helps them to kind of be an expert among their peers. For those that have already learned about simple machines and energy transfer, it gives them a different way to look at those concepts and apply them in a different way. Certainly, we're asking them to go through an engineering design process, and it's amazing to hear them articulate the importance of not of the engineering design process being cyclic, and that sometimes it doesn't work, so you have to go back and start that cycle over again. And so learning that when things don't work, it doesn't mean you give up. And that's one of the things they also really are able to really express in dramatic terms, that their machine doesn't work right on the first time, and often it doesn't work right after 50 times, but they can tell you they didn't give up and they kept going, and you can see that the pride in themselves and the enthusiasm that they have, that even though it took a long time to get it there, their final product is something they're proud of. And the engineering design process certainly helps them get there. And then the theme changes every year, every other year. So there's some knowledge that can be built around the theme challenge. So this year around feeding the animals, and we have had two virtual challenge. One where we've talked to some industry experts related to feeding to animal feed. So one of our virtual design challenges we met with and learned from a feed mill operator, and the other one that we just completed was with an animal nutrition laboratory manager. So certainly there's some knowledge that can be gained from specific to the task. So simple machines. We're asking young people to have at least one of the simple machines in their machine. They can certainly have more, and it's a fun way for them to learn about how to apply simple machines in a small scale. So the simple machines that, again, is a review for those that have been through it, but new information that helps young people understand it when have some knowledge when it comes to school. But a pulley, a lever, a wheel and axle, a wedge, inclined plane, and a screw. And commonly, as you might suspect, we often see the inclined plane. We'll see some pulleys, definitely some wheel and axles. I've seen a few screws, and that's been kind of fun. Levers we've seen as well. So I'm trying to think if I've seen a wedge. And I have seen a wedge, maybe not as it's used to doing work to break something apart, but to hold something in place. So young people learn about simple machines. So they're getting a little bit of basic mechanical engineering here by learning about simple machines. Then we're also hoping teams also learn about energy transfer and understand the concept of potential energy. So what that term potential energy means, and how potential energy can be, how that energy is transferred into kinetic energy or moving energy. So again, we're getting young people familiar with some of those words so that they do have some of that working knowledge when they go into school, or again, can apply it and think about it in different ways, or help their team if they've done this in school. It's fun to watch them synthesize their knowledge into a new way of using their knowledge. But certainly that's some of the knowledge that we're hoping young people gain from the teams. Then the engineering design process, and this is one depiction of an engineering design process. In this one, there's 5 steps. I've seen other ones where it's simplified. I've seen other engineering design processes where they're more complicated. But the elements of this are in every engineering design process, and I'll walk through each of these steps. The first step to an engineering design process to be really clear what the problem is. So that means oftentimes it's asking a young person to put it in their own words. What is the problem that we're trying to solve? But it's not enough to just understand the problem that we're trying to solve. And this is a really big leap, and a good way for young people to help think about problem solving is we not only need to know what the problem is, we need to know what our limitations are. So I'll pull in the word constraints so they learn, so they're getting some vocabulary in there. But also really important into not just knowing what the problem is or what your limitations are. But before you get going, to understand what it means to have to be successful. So what are your criteria for success? So in the Rube Goldberg in the engineering design challenge, we've given you some criteria. You need to have 7 steps or transfers of energy. We want young people to be able to describe what a simple machine is and where one might be in their machine. We want them to talk a little bit about the types of energy transfer that's happening in their machine. So we do provide some criteria in there, but teams will often have a particular step that they want to work in a particular way. So they have to be really clear about what that step needs to do in order to be successful as a successful step in their machine. The second step in an engineering design process, second stage, is to really start imagining ideas. So this is the brainstorming session. So you can go online to research different ideas for Rube Goldberg. If you've ever done a workshop with me, you know that my favorite one, and you can Google this, is the page turner Rube Goldberg machine. It's one of my favorite ones because it's a good illustration of what a Rube Goldberg machine is. But so that's to say, researching ideas can come online. It can be brainstorming with each other. It can be looking in your community. We want young people to start brainstorming ideas. And this is where sometimes it's helpful as to have that adult come in to help young people not get stuck in the brainstorming session, but to have some ideas and then be able to pick one. And so when they've picked an idea as a team, and that's also a good process, is to learn that decision-making process for a team. But then they need to plan it out, and that may be that writing out the steps, and that's a good part of journaling, is to start writing out your steps. And then it's fun to go back and see, where did we start with? What steps did we start with? And what are our final steps? But write out what the steps are, and then look to see what materials you have. So sometimes what you thought you might be able to, what a team thought they might have been able to do with a step, they don't have the right materials, or they just can't get it to work that way. So this is that planning stage, and this is a really good stage, I would say, for young people, but probably for all of us, is to put more time and effort into these the planning stage. It's a really tough but a good lesson for young people and all of us to learn, because we all want to go right to the create and the build step. We all want to start building. And this is sometimes where I see, to stereotype a little bit, I sometimes see girls get a little frustrated with their boys as teammates, because the boys want to go right into building. The girls want to spend more time in the planning. So it's trying to strike that balance. And girls can sometimes get frustrated because they don't see that they're not understanding where the boys might want to go with it. So there's sometimes, again, a communication helps a team to communicate, where girls might want to spend more time planning, the boys might want to do more trial and error rather than planning. So how do you meet in the middle, or what's the balance for your team? But this is the step, like I said, that we all want to get to, where we're getting to build it and test our machine. And this is the fun part for kids, and it's also one that as a facilitator, you sometimes have to keep them going to not get stuck on one step. In fact, I had one team, it was their second year, and I was judging them, and I remembered them from the year before, and I said, so what did you learn from your first year to their second year? And I wouldn't have thought of this, but this is a good illustration about this how a facilitator can help them get through this, but this team learned it on their own. And they said, well, one of the things that we learned is when a step isn't working, rather than just keep trying it over and over and over again, sometimes it's better to just change the step. I thought, yeah, and what a great lesson for them to learn, but also to be able to describe what they learned. Like it just seemed really powerful for them to be able to learn that within a hands-on way. So once they've started to build it and do those testing, then that's where that critical thinking and some problem solving comes in, because we want them to really look at their design and think, what is really working well with our design, or what part of our step is really working, but what's not working? And I'll give you my secret. When I'm working with kids, I have 3 magic questions. I want to lean into what's going really well. I want to start there. What's going really well with your design? What's working really well? My second question is, what's not working so well? And then sometimes that third question, unless you ask it, sometimes teams just don't get there. But the third question I always ask is, what can you do to fix it? And it's just like it opens the doors for them to try to make some changes and try new things. And what I do like about looking at this as a cycle is for young people to understand, and this is actually important when we look at engineering projects in 4-H. An engineering project is never done in one cycle. Engineers almost always want to go back and try things again to see what the effect of that change might be. And another key role that facilitators can play too is to encourage young people because they have lots of things they want to change. Let's just change one thing or one variable at a time so that we can see the result that one variable had on the end result. So having young people go slow and not make all the changes at once and having them journal and take some notes can be really valuable for lesson for young people, but it's also something that a facilitator needs to help them with, particularly as they're learning. So the team journal and the presentation. So in the guidebook on this left-hand side is an example of things that you could have a team journal about. What ideas were discussed, what things that you tried, what was a problem you ran into today, how did you fix it, how did you work as a team? So what ends up being meaningful for teams. Then the example on the right is just an example of how one team laid out their steps of how their machine was going to work. So again, just a guideline for young people, but it is a valuable lesson for young people to learn how to take notes and go back and review their notes. They'll also be doing or they should do a presentation, and the more experienced teams, the second and third year teams are better at this than the first year teams. But they've put all this work into creating this machine, and it should have a theme, and the animal theme, it lends itself really nice to thinking about a theme. So as you're getting ready to showcase or demonstrate your machine to the judges or to the audience, what's the story you want to tell around your machine? So that's where thinking through the presentation can be really helpful and engage team members in different ways as well. So keep that in mind as you're building your machine. And it's a different way to engage people our kids so that they're not always frustrated with getting stuck on one step, because that will happen. So then the showcase itself will be typically done to a judge or a group of judges, and it will often be a chance for young people to talk about their theme, to demonstrate their machine. And I will say too, you'll see in the guidebook, particularly if they've built their machine in one place and then you move it to the fair, wherever they're going to be showcasing it, inevitably there's going to be a step that's just a real hang up because you've moved the machine. And so there's a human intervention. So we understand that, our judges understand that the machines have been moved, and some of the precision pieces don't always line up after moving. So you'll showcase your machine, you'll hopefully a team will have some type of theme or presentation. The judges and the evaluators will ask you some questions about your machine, typical of 4-H conference judging, of really looking at your machine, but also, as if you've worked with 4-H youth, you know that one of the things that we really try and highlight is, what did the young person learn through this project or this process? So having a team think about the things that they learned in addition to creating their theme and their story, but what did each individual young person learn? And another hint or things for teams to think about is you want to share the wealth and the wealth of knowledge of what teams learn. So that's sometimes nice about a presentation too, is you can give each team member a speaking role so that they do have a way to showcase their knowledge to the judge. But we do want, when the judges ask questions, you don't encourage your team to not be dominated by one member. And that's often really fun, is to see some of those members that are leaders encourage some of their quieter members to, why don't you answer this question, or you're really good at this question. So helping young people know that not to rely on just one young person to do all of the discussion of what they've learned. We want the judges are looking for what the team and individuals have learned overall. So that could be certainly part of your practice sessions. Then in terms of what we have for support for teams, of course, you've got your local agent. And and look below the description of this video, and you'll see some links to the resources that I mentioned earlier. So those web page resources are a good place to start. Think about too in your community who you might have to help you with this year. If with your the theme of animal nutrition, depending on the animal that you pick, maybe there's an animal that species of the animal expert in your community that you can talk to just help young people learn more about animals, and maybe that it can be incorporated into their machine. Or sometimes maybe you need a woodworker who can help you build a frame for your machine. So look to your community of ways to encourage people to help or to be a resource for your team. And then certainly I am more than willing. I love this event for many reasons, but I am definitely willing to be a resource. So don't hesitate to reach out to me. And again, I'm Margot Bowerman. I'm the 4-H North Dakota 4-H STEM specialist. My email is margotbowerman@ndsu.edu. But with that, that is what I have for the presentation for today. Again, if you have any questions, please don't hesitate to reach out to me. And I hope to see you and your team at an event, if not this year, then maybe next year.